In this video, I will explain the specific heat capacity. I will start with the question. Here we see two blocks. They both have a temperature of 30 degrees Celsius, but they are not made out of the same material. Now try to answer the following question. Which block needs more energy to heat up 1 degree Celsius? Actually, it is not possible to answer this question because these two blocks are made out of different materials. We need to know the specific heat capacity for each of these two materials before we can answer this question. In fact, the specific heat capacity is a property of the material. Let me give another example. Water has a 5 times bigger specific heat capacity than sand. So heating them up by say 1 degree Celsius, you need 5 times more heat energy for 1 kilogram of water in comparison to 1 kilogram of sand. Likewise, 1 kilogram of water releases much more heat energy than 1 kilogram of sand when the temperature drops. So the quantity, the specific heat capacity, is a material property. And the definition is the amount of energy in joules needed to raise the temperature of 1 kilogram of a material by 1 degree Celsius. We abbreviate the specific heat capacity with the letter C, but now it's not a capital but a small cap C. And the unit for specific heat capacity is joules per kilogram per degree Celsius. So, in order to work with the specific heat capacity, we have to use mass. As you know, mass is a quantity which abbreviate with the letter m, and the unit is kilograms. This is the equation with which you can calculate the specific heat capacity. It's the heat energy divided by both the mass and the temperature difference. Now try to rewrite this equation in such a way that we can calculate the heat energy, mass, and the temperature difference. Pause this video to write down your answer in your notebook. Now I will show you the result of rewriting the equation of specific heat capacity. For heat energy, it's C times m times delta T. For mass, it's Q divided by C and divided by delta T. And for temperature difference, it's Q divided by C divided by m. Let's try to use this information for a question. This is a question which you can also find in your digital reader on page 25. How much energy do we need to heat up 2000 grams of water so that the temperature rises 5 degrees Celsius? For this question, you can use the table 1 with specific heat capacities of different materials. Pause this video to write down your answer in your notebook. Did you manage to find the right answer? Let's have a look. First of all, this is the information you can find in the text and the table. The specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. The temperature rise is 5 degrees Celsius, and the mass is 2 kilograms. It's important to write down the mass in kilograms because, as you can see in the table, the unit of specific heat capacity contains kilograms. My plan is to use this equation Heat energy equals C times M times delta T. Then I fill in the numbers, and I will find the number 42,000 joules. That's the heat energy needed to heat up 2 kilograms of water, giving it a temperature rise of 5 degrees Celsius. Now you've got an idea of how to use specific heat capacity in joules per kilogram per degree Celsius.